All right, good morning or good afternoon or good evening. Well, for me, it's Thursday, week 1 of term 2. For you, I don't know when it is. You could be in the future, and this is my past self talking to you, and I don't know, this is weird. So today we're looking at exercise 6C or 7C, equations of lines. This is all stuff you've done before. So if we're looking at vertical and horizontal lines, then I'm just going to draw my axes. A vertical line goes straight up, yeah? So I'm going to call this A. And it doesn't matter where on this line, up or down you are, what Y is, doesn't matter. X is always going to be A. So we use the equation for vertical lines. It's just the equation X equals A. For horizontal lines, green. Going along here, we have something fairly similar happening. Let's call this one B. Doesn't matter how far along you are, Y is always going to be B, yeah? And just for some extra information, what is the gradient of that horizontal line? It's 0. What's the gradient of the vertical line? You know, we're thinking puff, puff, positive, nice, negative, or undefined. Because remember, gradient is rise over run, and here the run is how far along in the x direction it goes, and it's rise over 0, and you can't divide by 0, so it's undefined. Okay, gradient intercept form. You remember this? Well, you will. Y equals mx plus b, where m is your gradient, which is y2 take y1 over x2 take x1. B, or do they call it C in this course? Hang on. C in this course. I can't remember which one I taught you in year 10. It always changes. It actually doesn't matter because it's literally just a constant. It's just the number at the end. So I don't care if you call it B or C. Is the y-intercept. So if you've got a straight line and it's going up like that, this is C, where it cuts through the y-axis. And if we have 2 points, x1, y1, x2, y2, it's fairly easy to find the gradient and then be able to chuck it in this thing. Quite often, they'll just give you 1 point and the x-intercept. So the x-intercept, what's x at this point? 0. What's y at this point? C. So that might be your x1, y1. General form, in the textbook they say quite often it's useful to have this in general form. It's not, it's never useful, but they make us do it because they like playing with our lives. So the general form is ax plus by plus c equals 0. The problem with this though is this c is not our normal c. So, this is one of the reasons I hate it, and it's never useful, but if they ever ask you to put something in general form, you get everything over to the left and then have equals 0 on the right. You'll see what I mean when we do some questions. So, question 2 asks us to find the x-intercept and y-intercept of each line. Now, we've drilled this into our heads so many times in chapter 3. The x-intercept, y equals 0, y-intercept, x equals 0. So, let's do it. Let's find the y-intercept first. So x equals 0. So we've got 3 times 0 plus 4y equals 12. So 4y equals 12, so y equals 3. We've got the y-intercept. The x-intercept, y equals 0. So 3x plus 4 times 0 equals 12. So 3x equals 12. So x equals 4. Like, this is much nicer than when we had quadratics. Y-intercept x equals 0. Well, you can already see that this is going to disappear and you're going to be left with negative 6, yeah? X-intercept y equals 0. So we've got 0 equals 4x take 6. So now we're going to have to actually solve for x. We're going to move the 6 over to the other side. 6 equals 4x. So now we're going to divide by 4. So 6 over 4 equals x. And that's the same as 1.5. Or 3 over 2. Doesn't matter. I like you to leave your gradients as a fraction, but with the x-intercept, y-intercept, it really doesn't matter. Often it's easier to sketch if you've got it in decimal because it's easier for us to visualize where it is on a number line, but it's personal preference. Y-intercept, x equals 0, so we've got 0 take 2, y equals 8, so negative 2y equals 8, divide by negative 2, y equals negative 4. X-intercept, y equals 0, so we've got x take 2 times 0 equals 8, so x equals 8. Not bad. Question 4 asks us to write down the equation of the vertical and horizontal lines through these points. Now I'm going to do this at great length for A, and you'll see immediately how easy it is for the rest. So the point 1, 2 is here, yeah? The vertical line through this, you can see it's x equals 1. The horizontal line through this, you can see is y equals 2. So it's just like x, y. So for B, the vertical line is always just what x equals, so x is 0. The horizontal is y equals negative 4. For C, something the same, well, something similar, so vertical line, it goes through x equals 5. The horizontal line goes through y equals 0. Does that make sense? Yeah, I kind of have to always draw it out for the first one to remind myself which is which. You'll get that. Gradient and y-intercept. Now, the beauty of this is all of these lines are in the form y equals mx plus b, where m is the number in front of x and it's the gradient, and b is the y-intercept. So for A, gradient is 4, the y-intercept is negative 2. For B, you tell me, what's the gradient? You're right, I hope, 1/5. The y-intercept, negative 3. For this one, what's the gradient? Don't forget the gradient's what the number in front of x. So it's negative 1. The y-intercept is the constant number, so that's positive 2. Here the gradient is what's in front of x, so it's negative 5 on 7. The y-intercept is, well, that's plus 0, isn't it? So it's 0. That's fairly simple. Like, you've done all this stuff before. It's not, you're going to smash this exercise.